So this problem could be done in an alternative way than we just showed. It can be done by keeping the r and the h variables. Now it's going to be a little bit more complicated, and we're going to need to use implicit differentiation to do this. But instead of making this into one variable, in terms of h, for example, what we did before, we can keep the r and the h and differentiate this implicitly. Now, just make sure you understand this is going to be a little bit harder than if you just converted it to one variable, but it can be done. So the way we do this is first of all, we have our rate, our volume, or sorry, our dH by dt rate. We have the R to H ratio is 8 to 20. And then I saw actually just change this, just rearrange this so I get R is equal to 2/5 of the height. So we can figure out how to get R based on the height. Okay, and in fact, at this point, maybe we will just calculate the height, the radius, based on the height of 12 centimeters. So we know when the height is 12 centimeters, which we were given, we know that the radius must be equal to, in this case, it's going to be 4.8 centimeters. Okay, so we have the dimensions of the radius and height at this point. Now, what we want to do is we want to differentiate this expression, v, I'm just going to simplify this to pi over 3 r squared h. And we want to differentiate this and get dv by dt. Okay, to do this, we need to differentiate this expression with respect to time, but we also have to keep in mind that there is a product involved in here, so we're going to have to apply product rule. So this is what it looks like when we differentiate this. So I'm going to differentiate this implicitly, and I'm going to keep it in, this is the implicit differentiation part here. So I'm going to differentiate the r, so I get 2r. But since r is an embedded function, I need to apply the chain rule and do dr by dt. And then I have times by h there. So then I need to apply the product rule. So I differentiated the first function. I'm now going to differentiate the second function. So I'm going to leave the r squared by itself and differentiate h. When I differentiate h, I get dh by dt. Okay, so this is my derivative with respect to time. This is my dv by dt. Now, I need to then fill in these parts. So what parts do I know? Well, I know dh by dt, that was given to me. I've calculated the r value of 4.8, so I can put 4.8 into here. I was initially given the height of 12, so I know this part here. Really, I just need to know dr by dt. So how do I get dr by dt? Well, if I take a look at this expression here, I know the r value is equal to 2/5 the height. That means that the change in the r, or dr by dt, is going to be 2/5 the change in the height, or dh by dt. So I'll just differentiate this expression, the right-hand side and left-hand side, with respect to t, and that generates this expression. Well, I know what dh by dt is. I was given that at the beginning. I know that's equal to 1. So then I can calculate dr by dt as 2/5 times dh by dt, which was 1 centimeter per minute. So then this works out to be, and I'm going to need to choose a color here. Let's choose this dark blue, and this works out to be 2/5 centimeters per minute is my dr by dt. So that's what I'm going to fill in there. So I'm going to maybe choose what color here. I'll choose pink. That dr by dt is going to be filled in with that. So I have all the parts I need then to be able to solve for dv by dt. I'm just going to plug in everything into this expression. I just got to make sure I collect all the parts. So pi over 3, 2 times, well, I have 4.8 as my r, so I'm going to fill that in. my dr by dt, well, I figured that out as to be, that was 2 over 5, or 0.4. Okay, my h, I know it's 12 centimeters, plus the r I know is going to be 4.8, so it's going to be 4.8 squared. My dh by dt, I was given as 1 centimeter per minute. So those are all my parts here. So now as I multiply this all together, I'm going to end up with 1728 over 25. Okay, and that's going to be the same as what I had before. So this simplifies to 1728 over 75 pi. And again, that's approximately equal to, I forgot what that value was. Let me just type that in. It's going to be 72.38, and it's going to be centimeters cubed per minute. Now, if you compare this solution to the previous one, this is far harder to keep track of because we are differentiating this implicitly and applying the chain rule with respect to time. So this is a little bit more, there's more pieces to have to keep track of, and we have to generate some other pieces in here because we have to generate our dr by dt and also figure out the radius, because everything was given to us in terms of the height. But because there's a ratio of the radius to height is always 8 to 20, we can figure those parts out fairly easily.